Hey, good morning, everyone. Today, I'll be presenting on kernel synchronization methods. These include atomic operations, spin locks, semaphores, mutexes, and comparison variables. So these mechanisms are important for handling concurrency in operating systems. So this is the set of contents that we'll go through today. There we have introduction to synchronization, race condition, need for synchronization, kernel synchronization methods, which include atomic operations, spin locks, semaphores, mutexes, and completion variables. Then we look at a comparison for all these methods, and then we'll look at the conclusion and references. So, what is synchronization? Synchronization is a condition of multiple processes or threads to ensure safe access to shared resources. So, in a multi-threaded system, multiple threads that are present may try to access the same data at the same time in the shared resource. So, without synchronization, this can lead to inconsistent results. So, the operating system kernel provides a mechanism to control this access and maintain correctness in the data. So, what is race condition? Race condition occurs when multiple threads access the shared data at the same time in the shared resource, and at least one of the thread modifies it. So the final results depends on the order of the execution, which is unpredictable. So this can lead to an incorrectness in the output. So here we can see a diagram. There are two threads that are working on the shared variable. Okay, so the shared variable is named as counter, which has been set to a value 5. So both these threads read the value as 5 of the counter at the same time. And then both of them increment it to 6 independently, as we can see here. The value of this counter, which is 5, is supposed to be resulted in 7, but the final value becomes 6. This happens because one of the thread overrides the other one, and this problem is called as a race condition. Now, the need for synchronization. The synchronization is required to prevent race condition and ensure correct execution. It provides mutual exclusion, which means that only one thread can access the shared resource at a particular time. It also protects the critical section, which is a part of the code where the shared data is accessed. And there, without synchronization, problems like deadlock can occur. So when many processes wait forever or leads to starvation, where a process never gets a chance to execute itself. Now, what are atomic operations? So, atomic operations are the simplest form of synchronization. These operations execute completely or none at all, meaning that they cannot be interrupted by other threads. They are supported directly by hardware and are used to build more complex synchronization methods. So, here we have an example which is called as test and set and compare and swap. So, the working of test and set lock include first we check the log value, and if it's unlocked, it is set to logged. And if it is logged, it keeps checking. It ensures that only one thread acquires the log at one time, and it is used in implementing spin locks. So the next one is spin locks. So spin lock is a locking mechanism where a thread continuously checks whether the lock is available. So this is called as busy waiting. It does not involve context switching, so it is faster for short waiting times. However, it wastes the CPU resources if the wait time is very long. So here we also have a diagram where we have two tasks, task A and task B. The task A acquires the lock first and then enters the critical section. And the task B tries to acquire the lock at the same time, but then it cannot because since task A has acquired the lock. So it keeps waiting in a loop. That is, it gets blocked until task A releases the lock. So once task A releases the lock, task B acquires it and then proceeds. This continuous checking is what we call as spinning. So this leads to spin locks. Next, we have semaphores. So semaphore is a synchronization mechanism that uses an integer value to control the access to the shared resources. It works using two operations, wait and signal. So the wait operation decreases the value and blocks the process if the resource is not available, and the signal operation increases the value and wakes up in a waiting process. So we have two types of semaphore, binary semaphore and counting semaphore. Binary semaphore has the value of 0 or 1, and counting semaphore allows multiple threads. So the key features include this prevents race conditions. It can allow multiple threads, unlike mutex, and it is used for resource management and synchronization. So here we can see a flow chart. So in this diagram, a process that first requests access to the critical section uses the wait operation. If the semaphore value is available, it proceeds. And otherwise it is placed in a waiting queue, and then it keeps waiting until it enters the loop. After finishing the execution, the process calls the signal, which increases a semaphore value and allows another waiting process to continue. Okay, next is mutex. So mutex is a locking mechanism that allows only one thread to access a resource at a time. A thread must use the lock mutex before entering the critical section and unlock it after finishing. So this ownership based meaning only that the thread that logged it can unlock it. So there are key points. It ensures strict mutual exclusion. It is ownership based, means that only locking thread can unlock it. It is much more simpler than semaphores, and it is used in both user level and kernel level. Again, we have a diagram here. In this diagram, the thread A locks the mutex and enters the critical section. The thread B tries to acquire the lock, but it is blocked. After thread A finishes and unlocks the mutex, the thread B is allowed to proceed. This ensures that only one thread accesses the resource at a particular time. Next is completion variables. So completion variables are used when one thread needs to wait for another thread to complete its particular task. So it is used in kernel level programming and it avoids busy waiting. That is, there is no spinning in this case. So when it comes to the working, there are two threads here. Let's call it as thread A and thread B. So thread A calls wait for completion task, and then thread B performs the task, and then thread B again calls the complete function. After that, thread A resumes its execution. So the key points here include it is an event-based synchronization and it is more efficient since there is no CPU wastage and it is used when tasks are dependent. Next, we have the comparison of the synchronization methods that we just looked at. So each synchronization method has different use cases. The atomic operations are fast and low level. Spin locks are used for short waits, but it wastes the CPU resource. Semaphores are flexible and allows multiple threads. Mutexes provide strict mutual exclusion and completion variables are event-based and avoid busy waiting. In conclusion, synchronization is essential in multi-threaded systems to ensure correct execution and avoid errors such as race conditions. So there are different methods that are used depending on the system requirements. And these are the references that I have used. Thank you.